So we're back on 314. And what we do to talk about the interior angles of any polygon is we basically break those polygons down into triangles. So you have a quadrilateral drawn up here, and we pick a corner, doesn't really matter which corner, and we make sure that that one corner is connected to all of the other corners on the figure. You can see this one is already connected by the exterior line that actually makes the quadrilateral, and so is this one down here. But this dotted line in the middle, this needs to be connected so that all the corners are connected to each other. What that does is it breaks our quadrilateral into two triangles. And as we know, every triangle has 180 degrees inside its angles, its interior angles. So this plus this plus this would be 180. And then down here, this and this and this would be 180. So the two triangles total, when you add up 180 and 180, would give 360 degrees for the interior angles in the whole quadrilateral. So it says draw the number of diagonals from any one vertex of each polygon, then state the number of triangles that are formed. Well, of course, a triangle, if we start with one corner, we've already connected the other two. So the number of triangles is 1. The number of degrees is going to be 180 times 1, which is, of course, 180. We just did a quadrilateral. Let's do it again. Pick a different corner this time and see if it comes out any differently. We're going to pick a corner, connected already. This one needs to be drawn. This one's connected already. So we have two triangles, and the number of degrees would be 180 times 2. Here we have a pentagon. We're going to pick a corner, any corner. Make sure that all of your angles are connected. So there's one that's connected. Here's one that needs to be drawn. Here's another one to be drawn. This one is directly connected. So we now have 3 triangles. And our number of degrees would be 180 times 3. I hope you're catching on to a pattern here. So down here, we have a hexagon, even though it's very irregular. I'm going to start over on this side this time. That line is connected, that corner is connected directly. This one needs to be directly connected. This one needs to be directly connected. This one needs to be directly connected. So in our 6-sided figure, we have 4 triangles. And so our number of angles would be number of degrees would be 180 times 4. Then we have a heptagon, 7 sides. Pick a corner, connected already, needs a line, needs a line, needs a line, needs a line. So we have 1, 2, 3, 4, 5 triangles, and our number of degrees would be 180 times 5. Over here, pick a corner. I haven't gone this way yet. That one's good. We need a line there, we need a line here, we need a line here, need a line here, and a line here. Now we have all of our diagonals drawn. 1, 2, 3, 4, 5, 6 triangles, and 180 times 6 is the total number of degrees. So as we fill out the chart, okay, the number of sides was 3 on the triangle, and the number of triangles was 1. So we did 1 times 180, and that gave us 180. On our quadrilateral, we had 4 sides that broke into 2 triangles, and our total number of degrees was 2 times 180, which is 360. Our pentagon had 5 sides and 3 triangles, so we said 180 times 3 was going to give us the total number of degrees. Hexagons have 6 sides, and we got 4 triangles out of that. And then we took 4 and multiplied by 180 to get the total number of degrees here. The decagon would have 10 sides. We haven't actually done a decagon. And so we need to look and see what this pattern was. So 3 to 1, 4 to 2, 5 to 3, 6 to 4. And I hope that what you see is that you have this number of sides, which we're going to represent as n, and all of the numbers in this list are 2 less. So n minus 2 is how we're getting this number over here. So 3 minus 2 is 1, 4 minus 2 is 2, 5 minus 2 is 3, 6 minus 2 is 4, so 10 minus 2 would be 8. And even though we don't have that drawn out, we can see that this pattern fits all of our examples, and it makes sense that it would continue. So the number of degrees in that figure would be 8 times 180. So the formula that's not actually written anywhere that we want to make a really, really big deal about, because it's going to save you from drawing out all these diagrams. The big star at the bottom, and we're going to put n minus 2 in parentheses times 180 equals total degrees in any convex polygon. Let's highlight this instead. There we go, n minus 2 times 180. So they go over here and they look and see how many sides. You have 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So to find the total number, you find the number of sides, you plug in 9 in this case, and just simplify. So 9 minus 2 is 7, and 7 times 180 is 1,260 degrees total in the entire thing. So if we're trying to find this little missing angle up here, you're going to take all of the known angles and add them up, plus our missing angle, and set it equal to 1,260. Okay, and so you're going to subtract all of these from 1,260, and that leaves you with a missing angle of 58 degrees. On part B, we have the same kind of problem, but we don't have a picture. You don't need a picture for this though. All you need to know is how many sides it has or what the sum already is. It says determine the unknown interior angle measure of a convex octagon, means it has 8 sides, in which the measures of the 7 other angles have a sum of 940. So the 7 other angles we already know. We have 940 for the 7 other angles, plus our 1 missing angle is going to be equal to some amount determined by our sum theorem. So we're going to say 8 minus 2 times 180. Now, if you want to, you can break that down into multiple steps. You could go ahead and say that this is 6 times 180, and you could write down 1,080 if you wanted to. But I just wrote it down all at once to show you that that's an option as well. So then we're going to subtract our 940. And our missing angle is 140 degrees. Seems like it's going to be a lot more complicated, but it's really not. It's just n minus 2 times 180 for the total in the entire figure. And then all of the known angles together plus your missing angle equal that amount. Let's look at number 6. It's a little more interesting example because you have 2 missing angles that are both the same size, x degrees, x degrees. It says determine the unknown angle measures in this pentagon. So pentagon means it has 5 sides. We could have counted that if we wanted to. So we know that our total has to be 5 minus 2 times 180. So 3 times 180 is equal to 540. Just going to write total out here. So if I wanted to, I could have started out with an equation like this where I had 5 minus 2 times 180. But just showing you that you can also break it down into multiple steps. So my known angles are all 90 degrees. So I have 90 times 3, or 270. 90, 90, 90. And then I have 2 x's. And that's going to equal, I could put 5 minus 2 times 180, or I could go ahead and put 540, either one. So the 3 90-degree angles plus the 2 x-degree angles have to have a total of 540, because that is what our sum theorem says. So we're going to take 540, we're going to subtract the 270, and it leaves 270. And then we cut that in half because we divide by 2. And x is 135 degrees. Now, I probably have some folks wondering out there, well, Ms. Wright, couldn't I just subtract and see how many degrees should be left and then cut it in half? And yes, you absolutely could. You don't have to set it up like this equation. It would be the exact same steps. So if you're wondering if there is a different way to go about it, a different way to write it down, yes, as long as you're following the rules and using the correct facts from your diagram. Number 7, determine the measure of the fourth interior angle of a quadrilateral if you know the other 3 measures are 89, 80, and 104. So we have 89, 80, 104, and our mystery angle, which we're going to use as an x. And the sum is going to have to be, well, quadrilateral has 4 sides, so this is 4 minus 2 times 180. And you simplify with your calculator or by hand. So 89 and 80 and 104 are going to add up to 273. 4 minus 2 is 2. 2 times 180 is 360. Then we take 360 and subtract this 273, and we find that our angle that is missing is 87 degrees. Not too bad. Last one before we move on. Determine the unknown angle measures in a hexagon, 6 sides, whose 6 angles measure 69, 108, 135, 204, B, and 2B. So we just add them all up, right? 69 degrees plus 108 degrees plus 135 degrees plus 204 degrees plus B degrees plus 2B degrees equals, I'm running out of room, 6 minus 2 times 180. Woo, barely fit. So now we get to simplify. 69 plus 108 plus 135 plus 204 is going to all add up to 516. B and 2B add up to 3B. 6 minus 2 is 4. 4 times 180 is 720. And that is a much more, much simpler looking equation. So 720 minus 516 gives us 204. And we divide by 3 to find that B is 68. Now it says determine the unknown angle measures, plural. B is one of them, but the other one is 2B. So 2B is going to be the same as 2 times 68, which is going to be 136. So now we have our entire answer, 68 degrees and 136 degrees.